Hello. Before starting, here I have a metal piece and just watch it carefully. If I apply slight force, then it regains itself, you can see. But if I increase that force, it has certain deformity in it. I can get it back, you can see. Then permanent deformity. And now if I continue to give this deformity, it breaks. Well, today's topic is elastic. So here I have this mask, and I'm not interested to tell you about this, but it's string, you can see. So we often call this as elastic, but in physics the idea is little different. So what is an elastic object? What is elasticity? We'll discuss about it in this chapter. So I will tell you about elasticity, but before that, we have to discuss about rigid body and deforming force. Well, what is a rigid body? A body which retains its original shape and size against external deforming forces. Means if you apply some force to deform it, it retains its shape. It does not undergo a deformation. This thing can also be defined in more technicality as a body whose constituent particles do not undergo a relative displacement from one another against external deforming forces. Ultimately, deforming forces, if they are there, if deforming forces are there, then they will make a body to get deformed. But if a body does not deformed, then that will be called a rigid body. So we know that when we apply a force to an object, that force has the tendency to accelerate that object. But if it is not accelerating that object, it has tendency to deform it. Like I'm applying force, I have tendency to deform this sketch. However, I'm not deforming it, but I can deform this. Now what is a deforming force? So a force which has tendency to deform a body, deform an object, is called deforming force. There is nothing more to discuss about it. And now the big one, elasticity. So the property of body by the virtue of which it regains its original shape and size when external deforming force is removed. So elasticity is not the property to being stretched. Elasticity doesn't mean stretchability, but it is the ability by which it regains its original shape and size. So each body has that elastic nature, that property of elasticity. It can be more or less. Like there are few objects which completely regains their original shape and size after being deformed. They are called perfectly elastic objects, and few which do not uh, regain their original shape and size. They are called perfectly inelastic object or plastic object. That plastic doesn't mean the plastic of this. That is the name of opposite of elastic object. So we can define two types of objects, two types of material. One perfectly elastic, other perfectly inelastic. So perfectly elastic bodies, those bodies which completely regain their shape and size after being deformed, they are perfectly elastic. And perfectly inelastic or plastic body, those bodies which do not regain their shape and size at all after being deformed. So examples are ivory, जिसे आप हाथी दांत कह सकते हैं, and steel. Here perfectly inelastic, clay, mud, and wax. There are few more terms we need to understand while studying elasticity. These are stress and strain. But before I will tell you about stress, let's talk about pressure. We know that thrust acting per unit area is called pressure. So P equal to thrust. Thrust means normal force, a force which acts perpendicular to the surface. So we will call it force casually upon area. So that is pressure. We know about it. Its SI unit is Newton per meter square or Pascal. There are several other units for pressure also, like atmosphere. In shortcut, it is written as ATM. when 1 atmosphere is equal to 1.013 into 10 to the power approximately 1 10 to the power 5 pascals. There are some other units also: bar, torr, and mm of Hg, that is mercury, or cm of Hg, millimeter column of mercury or centimeter column of mercury. I will discuss about it in another video. Otherwise, this will be very long. This is going to be very long video otherwise. Okay, now if we talk about stress, so it looks similar to pressure, but of course it is different from it. Actually, there's not a particular symbol for stress, but in many books I have seen sigma is written there, so that is why I'm using this symbol. Otherwise, I prefer writing it stress in words. So what is stress? It is internal restoring force acting per unit area of a body when deforming force acts on it is called stress. So when a body is subjected to any deformation, so in the same way there is internal restoring force. So if I am deforming something, then like this, if I deform it, so it tries to regain itself. So this is the deforming force which has stretched this spring. And when in the same way, now what is making it to regain its shape? I am not, but as I am applying force onto it, so also it is also applying, that is internal restoring force. There is a restoring force and there is internal restoring force. That is why it is being restored. So these are internal restoring force which are inside the material of that object. And that internal restoring force per unit area is called stress. So formula for stress, F upon A. So units are also same. I'm not going to write it again. So the question is pressure and stress same quantity or are they different quantities? So, well, formula wise, unit wise, dimension wise, they look similar. In fact, one is acting from out to in. Pressure, if we try to squeeze something, that is we have applied some pressure from outward to inward, but its molecules, its constituents are applying force to restore itself from inward to outward. So they look similar, but there is a difference. If we talk about pressure, then we talk about thrust. That must be normal to the surface. But stress can be divided into two categories. One is normal stress, and other one is tangential stress. Normal stress can also be studied in two ways. One is longitudinal stress along the length. When a wire is stretched, it was the wire and then it is stretched. So in this case, the stress developed in the wire is longitudinal stress, and other one compressive stress. Compressive stress, like we have a rubber ball and we have squeezed it. So at that time, the stress developed in its volume to overcome that compression. And tangential stress, if we had this cube and somehow we just deformed it in this way, means we have stretched it in this way so that it got deformed. One side is fixed and other we have somehow moved. So this kind of, then the stress produced, because it acts tangentially, deforming force acted tangentially. In this case, the stress produced which will make it to regain itself. So next is strain. So what is strain? It is the measure of, actually I'm not writing its definition right now. It is the strain, it is the measure of amount of deformation. How? The ratio between change in configuration to original configuration of a deformed body is called strain. So there can be three types of deformation. First, longitudinal strain, then volumetric, then shearing. Longitudinal, like this. Well, this is a spring, but consider it as a metal wire, and if I'm stretching it, if I'm able to stretch it. Then volumetric, like if we squeeze something. And shearing, if we change the shape of an object in such a way one face is remains fixed and other face shifts, uh, like this. So change in length upon original length. So we can define like ratio between change in length to original length is called longitudinal strain, volumetric strain. The ratio between change in volume to original volume is volumetric strain, and shearing strain. Uh, the ratio between shift, linear shift of one face over other uh, to the separation between two faces. It is unitless dimensionless quantity because it is the ratio of same quantity. So, so there are stress and strain, and on the basis of that, we can study the elastic behavior of material. So this is all about the introduction of this chapter. Next, there will be some other constants related to uh, elastic behavior of substance. So, so that's all in this video. So in next video, I will tell you about Hooke's law and some other parameters. That's all.